Hello there. Do you listen? Do you hear me? Hello everyone. Do you guys hear me? Thank you. Thank you for joining this session. So in this webinar, I'm going to train some machine learning algorithm using Python. It won't be very complicated. I will be using very simple data set. Okay. So first of all, let's see the data set. As you can see that for this data set, we have years of experience and salary, just a simple data set. So here we will be predicting the salary from the year of experience. And in the second data set, as you can see that there are some independent variables, and we will be predicting the profit. And this data set represents profit of a company where the R&D spend, administration, marketing spend, and state are given. Okay, so suppose a company is spending this amount of money in R&D spend, and this amount in administration, and this amount in marketing, and the state is in New York. So the profit for this company is this much. So we'll be training a machine learning model to predict the profit. And the third data set that I will train the model with is where we'll predict the salary uh, when against the level of the position, and we'll predict the salary there. Okay. So the algorithms that will be used are linear regression, multiple linear regression, and polynomial linear regression decision tree, and random forest.
Sayed brother.
So I will train these models using the data set there. So this session is completely for beginners who are not, very much experienced with Python and want to learn. So I will be showing how you can train this simple the model, the algorithm using this simple data set. Okay. So the tools and libraries that will be used are pandas. We will use
Brother,
CSV. Will be you know fetching the data from the CSV file. So we will use pandas library for that, and num and we will also use numpy, where whenever we are working with arrays, we must okay. Okay, then we'll be plotting the result using matplotlib. So first of all, for data preparation,
um, can I say now?
yes, Muhammad Ali, you want to ask any question?
Thank you so much, Sayed brother, for allowing me to speak. And I'm really sorry to interrupt you in between your super awesome session. Actually, I just want to remind everyone
Wait, I
that
can't hear you. Wait a second.
um,
Yes,
okay. Actually, I just want to remind everyone who is participating here that please do fill sign-in form for the Student Jam 3.0 activity if you haven't yet, because it's necessary for everyone, like for everyone, organizers, hosts, volunteers, participants, any scholar. We all are equal, so we all have to fill this form for once only. If you have already filled up, it's awesome. You don't have to fill it again. And thank you so much, Ahmed brother. You are doing super awesome. Go on and continuously inspire us. Thank you so much. You can carry on. You can carry on.
okay.
Thank you so much.
So I was talking about data preparation. We have uh, we need to scale our data. Suppose if we have too much different difference in the range, then we need to scale them to a certain range. For example, is in standardization, we basically target to make the mean 0 and standard deviation 1. And in normalization, we try to range the data set, all the values from 0 to 1. So most of the time we will use standardization, and for encoding, as we have these topics has been covered in our foundation course. And in encoding, we have categorical and one-hot encoding. And categorical, I mean ordinal. Ordinal means that you are representing a category with a numeric value. For instance, 0, 1. But one-hot encoding, you will be adding the for each category, you will be adding a column. And so I will be doing this in Python and show you how you can do that. So first, we will work with linear regression with the first data set, this one. The years of experience and salary, the relation are linear. I will show you in my code. I've already coded and tested everything uh, so that you know it saves some time and I can explain everything properly. Okay, so first in linear regression, we know that the relationship are linear. As the experience increased, so does the salary. So we will see this linear line, which represent the best fitting line, and these are the observation. And okay, so this is the equation of linear regression, where b0 and b1 are the coefficients, and in machine learning, while we train the algorithm with the data set, we try to figure out the value of these coefficients. That's what we do. So now let's try it with Python. As I already have the data set here. This is the data set for simple linear regression. So here I'm going to import first these libraries, NumPy, Matplotlib, and Pandas. And Matplotlib will be used for.
Sayed,
Yes.
I don't think that you're sharing the screen that you think you are. We're still on the linear regression slide.
Okay. Let me see. Sorry about that. I know it is my first webinar, and I haven't worked with Zoom before. So.
You're doing great. This can be a little weird with the screen sharing. You probably have to go back like you're going to start a new screen share and then just select the screen you want to share.
New share. Okay.
Yep,
Okay,
probably it will refresh the
see
page.
the screen?
Yes, it's perfect. Thank you.
Okay, so as I said, that first we will be importing the libraries, NumPy, Matplotlib, and Pandas. So just simply import them. I'm going to import. And now I will import the data from the CSV file, and here we are using the Panda library for importing the data. Okay, so this is the data set. We have salary and years of experience. Now, in this data set, years of experience is the independent variable, and salary is the dependent. We are going to predict salary. So salary is the y value, and here we are, by this column, we are saying that we want all the columns, all the rows here, from 0 to 29. There are 30 rows. So we are indicating that we want all the rows into y. Okay, we are importing everything. And one basically indicates that the salary, the column. So we are importing everything to y. And about x is the independent variable, and same here, we are importing all the rows, and we are importing this years of experience only. That's why we are, this basically this means that we want everything. So everything minus 1 means this years of experience only. We are importing x and y. So if we execute it, so now we have x is the value of for the years of experience, and y is the salary. We have got everything imported using the pandas library. Okay, so uh, in the Azure machine learning lab, we have seen that we split the data set into test and training section. So here we are going to do the same thing, but using Python, and we are using sklearn library, and we are just here saying that we want 1/3 of the data as test data. and others will be used for training. So, and here the X train will contain the training independent variable for training data. X test will be contain the test data for of independent variable. So that's how we are going to import everything and split. We are basically splitting here the data set into test and validation. So we have, okay. So now we're going to train the model. Basically, for feature scaling, like converting them into a certain range, we may not. It depends on the performance. If we see that we are not getting good performance with scaling, we should avoid. So yeah, for simple linear regression, that's how we
Sayed,
can do it.
maybe there's some mic issue.
Okay, wait a second. Do you have any question?
Yeah, could you just back up? Your mic cut out and kind of got a little bit fuzzy for just like the last 10 to 15 seconds.
But it's fine now, I believe, Rachel.
Okay.
Sayed,
Yeah, so just if you could repeat what you said.
Yeah.
So, do you hear me now? Is it clear?
Yes, yes.
Hello?
It's a little weak. Can you just put mic a little closer to your mouth? Sayed?
So, let me know if you have any problem or you cannot hear me. Let me know. Okay. So, here I have just basically splitted the data into test and training set. So we have here the X test, X train, Y test, Y train. So we have everything split for training. Now we for the last about feature scaling, I said that if your model performance does not increase by doing feature scaling, you can avoid it. You know, it's model, the machine learning is all about tuning the hyperparameters. If it does not improve your result, you can skip. So that's how you can do feature scaling in Python. Like scale everything, standardization, like scaling from mean 0 and standard deviation to 1. So that's how you can scale the feature. You just use sklearn and import standard scalar. And then for training dataset, you just pass the training set of independent variable here. It will just return you the scaled variable. And for X test, you just pass the variable here in. It will test the whole matrix for you. Scale the whole matrix for you. So that's how that's simple. That's how feature scaling is done in Python. And now about fitting. I mean the training. Here we are going to train the linear regression. So we are using sklearn and importing linear regression from this library. Then we are initializing the regressor variable. So now I'll just execute this, and you can see it is executed. There is no error. And now about we just executed it. Here we are just passing that X train and Y train. X train contains all the independent variable, means the here the independent variable is this years of experience. We are passing it here, and we are passing also the training data, the training the salary for that years of experience, and training the model. Basically, we're training the model here. And now about prediction. Just for prediction, we just call this variable, the object that we created, and pass the X test, and it will give us the predicted value for the testing data. Then we can compare this Y prediction with our actual value that we have kept, separated. We'll compare with this one. It is executed, as you can see. That means the model has predicted the y value for the test data, and these are the predicted value, and these are the actual value that we have kept separated. As you can see that for first value, the model predicted a bit higher. It was 37,000 and it's predicting 40,000. For second one is pretty close, and the third one is predicted a bit higher. So that's how the model has predicted the result for our test data. And for visualizing, if you want to visualize how our model has done, we can use the library that I mentioned previously, matplotlib. And you can see that I'm just passing the plot scatter, the x train and y train. These are the actual data points that I'm passing. Yeah, this is our observation. This I'm just simply passing what is in the data set, and we're getting this. Now, if we plot with the predicted value, we will get these are the model has created this line, okay, and our actual data point is this. These are actual observation from the data set. This is the prediction from the model. We are passing the x train, and we're passing the y value. This actually represents the predicted value here. We're passing the predicted value against the independent variable. This is the for training, and this is for testing. So we are testing our model with training data and also with the for both training and testing. So here you can see that's how the model predicted the line. So this was for linear regression. That's how you can train linear regression using Python. Okay, so for next data set, so we just trained linear regression using Python. So now let's move to multiple linear regression. When do we use multiple linear regression? If we have, uh, there are some assumptions that it has to be fulfilled if you want to do linear regression, as we have seen in the Azure foundational course. So this assumption has to be fulfilled first, and then if you have more than one independent variable, you will obviously choose the multiple linear regression. Here we opted this one because opted the linear regression because we had only one independent variable. And here we have multiple independent variable, and we will be predicting y value from x1, x2, x3, all the values, all the independent variables. So the second data set that we are going to work with is okay. So here we are going to predict the profit. We have in the data set we're going to use R&D spend, admin, marketing, and of course the state to predict the profit. And here you can see that everything is in numerical form except for this state. It's in text form. So in machine learning, as we have seen in foundational code, that we need to convert it into a sort of numerical representation. Otherwise, it cannot be processed. So here we have states. So basically, we are using one-hot encoding and representing this using the variables. These are called dummy variables. We are using this variable to represent the value for state, and we are here you can see that we are adding a column for each of the variables. New York, California. We have only two values for this column, so we added two variables there, two columns there. So when it's New York, there will be one here and zero in California. When it's California, it will be one here in California column. So that's how we convert this into numerical representation. So it's just basically same as linear regression, just the variables get increased, nothing else. And there is another important factor about dummy variables, that if you have like here we have two two values for state, but in machine learning we will be using only New York, not California. We are here we are trying to avoid the dummy variable trap. Okay, we are just uh, basically every machine learning, most of the machine learning algorithms, they just automatically identifies and they exclude the they just exclude the last one, so that because as we have studied in the Azure foundational course, that we do not want we want to reduce the dimensionality in our variable. Okay, for reducing the dimensionality, we just exclude the unnecessary columns or attribute. So here we can represent this state using okay.
Sayed, further, sorry for
So
the
here we
disturbance.
can just represent the state using just New York variable. We do not need California. If it's
Okay.
one, that's mean New York. If it's zero, that's mean California. So we are not required to have this column. So in machine learning, whatever is unnecessary, we just exclude that. So this is about multiple linear regression. So now let's move to the code and see how we can train multiple linear regression. So here, okay, so we have the data set here. We have the data set that I discussed earlier. We're going to predict the profit from the data set. So first, as we have done before in simple linear regression, we imported everything. Where we are going to do the same thing, just import everything, import it, and we're going to import the data set now. We have the data set in the same repository, that in the same folder, and the data set is imported. Okay. So our data set is imported, as you can see, and I'm just simply importing everything from CSV file. So here, this is what we are going to predict using all these variables, and we will need to convert it into into numeric format using 114 coding. I'm going to show you how you can do that using Python. Okay. So first, we will import the independent variables. So let's just import them. X. So here, independent variable is going to be just everything except this one. Everything except profit. So we are saying we want everything except the last, everything minus one. That means we want R&D spend, administration, marketing spend, and state. These are all X value. And these are the only Y value. And here we are mentioning that it's in the fourth column that we want it as Y value. So Y is also imported now. So here we are going to encode the categorical variable, as I have said. This categorical values into numeric format. I'm just importing the 114 encoder, yeah, the from the library here, sklearn library. Okay. And here we are saying that we want our third column, which means 0, 1, 2, 3. That means this way, this column, we want to convert it into numeric format. So just here we're just into the level encoder, we're just fitting the state and converting it into a numeric format. Okay. So as I mentioned earlier, that we want to avoid dummy variable trap. Which means we want to exclude the last variable. We do not need to do it manually, as most of the algorithm will do it by itself. But here we are just excluding the last variable, means okay, means as as I have mentioned, that we're just excluding this California here. We're doing it manually, but you do not require to do it. I'm just, for explanation, I'm just showing you that which is required, that it has to be, excluded. But the algorithm does it itself. You do not need to do it. And same here, we are also splitting the data set. We are defining that we want 20% in the test data and others 80% for training in the training data set. Okay, so we have imported everything. We have X train, X test, everything imported. And here we are just simply same as the previous one. We're just calling this, creating the object of regressor and passing the Y train and X train to train them. And this regressor will now be able to predict the Y value for our X when we give it to the X value. Okay, it is executed. So this is our regressor, it's trained. Now we can use this to predict for our test data. As you can see, X test, we're passing into the predict, and it will give us the Y predict. prediction value for y. Okay, so here this is the predicted value, and this is the actual value. A predicted value we can say is pretty close. Yes, it's pretty close. So that's how you can train multiple linear regression in Python. Okay, now let's move to the next data set. Okay, so we've trained uh, multiple linear regression using Python. So we will use polynomial linear regression. And when do we need polynomial linear regression? If our data set is not linear, so we will we can use polynomial linear regression. And you can see that it's also called linear. It's called linear due to that you can say that the coefficients are same as linear. Okay, the only the things that change are only the value of the independent variable. X1 it get x squared, x to the power n. That's how it changes. But the coefficients have linear relation with y. So that's why it's also called linear regression. If you had something like b naught divided by b1 plus b2, something like that, then it wouldn't be called. It wouldn't be a linear relation as it's represented. So that's why it's called okay, polynomial linear regression. So the data set that we will be using here is this one. And okay, so let's move to the code. And here you can also for y variable you can wait, yeah. So here we are going to train polynomial linear regression using the data set that I discussed, and we're going to do the same. We're going to import the NumPy, matplotlib, and pandas. So now we'll import the data set from the CSV file. The data set is imported. So this is the data set. And here you can see we have position, level, salary. Actually, the level is representing the position. If you use a business analyst, level 1, junior consultant, level 2, level 3. So this actually this particular column is not required. It's being represented using this level. It's just you can call it just ordinal encoding. You know, it's already prepared there. It's already ready. Okay. So we're going to use this level to predict salary for this. And if we see here, we are importing we are only importing here, we are saying that we want the second column. It means in Python we define if you want this row, we write it like this: one column two, which indicates that we want the column one. If you want column 4, like suppose we had 4 columns. So if you want third column, you can write here 3 and 4. So that it will only catch the lower value. So which means that we want the third column. So here we are saying that we want the first column means this is represented as 0 and this 1 and this 2. So we want only level here as independent variable. We are importing it. The X is imported. And why we are importing the second one, which means second column. Okay. Here we can see the relationship here. You see, it is not a linear relation. You can see it's a curve. As you can see, it's a curve, and so that's why linear model not is not going to fit here. It won't it won't be able to predict the y value properly. Okay. So here we are just first we will try to see how linear regression performs here. If we train it with linear regression and we just plot the data. So here we are just training the linear regression model with x and y. We're not splitting anything here, just to show you. And this is how you can train polynomial regression. So first I will show you how the linear regression performs here. As you can see that the linear regression is only is creating a linear line, which is not fitting the data properly, especially for this one. So here linear is not performing well. So we are training polynomial linear regression. We are importing the polynomial algorithm from sklearn library, and here we can define the degree of if you let me show you the slide. So here this is n degree. If you have degree 2, it will stop here. So degree 4, it will go till when n is 4, n equal to 4. So every degree increases, the performance increases, but you have to be sure, make sure that it does not overfit the data. So you have to be careful about that when you increase the degree. So it's just a hyperparameter that you increase. So if you train, suppose we want to, we train it with the 4 and see how it performs. So let me explain you the code for we are just importing the polynomial regression object here, and we are just simply fitting the x independent variable here, and it's returning us x poly. Means x poly means actually means let me show you the slide again. X poly means x1 x1 square x1 to the power n. So it's returning these values. So we are just getting x poly, and now using this x poly, we will train the polynomial regression. Okay. As you can see, we are passing the exponent into linear regression as it's called polynomial linear regression. So, and there's a relation, there's a linear relation with the coefficient. So we are still using a linear. We're just using this particular function to convert x poly to get the x poly, and then we train the linear regression. And if we visualize, you can see that this polynomial linear regression is performing better in this case. Where when you compare it with linear regression, it's just drawing a random, just a linear line which does not fit the data properly. So what happens if we decrease the degree? There are being 4. What if we give degree 2? As you can see that the performance has it's not fitting very well. When you use degree 4, it fits better. When you use degree 3, now you can see it's fitting bit better than the previous one. But degree 4, it's better fits the data. It's a good fit. It's a good fit. So that's how we can train polynomial regression. And if we predict the variable, so suppose we have here in the data set, we can see that, let's see how our polynomial linear regression performs. For level 6, we get this amount of salary. What if for level 6.5, how much will the the salary will be? So if we use this polynomial regression to see the value, okay. For you can see here that for if we predict the value with linear regression that we trained, it says that this for position 6.5, for level 6.5, we should be paid 33,000. This amount of money, but which is not, if we compare with our actual data, you can see it's a bit higher for actual data. 6.5 is even exceeding level 7. In linear regression, it's not predicting the data properly. So 6.5 is saying that we should, which is showing the data even crossing the level 8.
Sayed, this is Rachel. Are you showing a different screen than just the data set data frame? It seems to be stuck on that.
I'm showing the code. You can't see the code.
The code is to the left, but the data set data frame pop-up is in the center.
You cannot see this screen.
I can't. I don't know if anybody else can.
Okay. You cannot see the plot and
No, the data set data frame pop-up is like in the center of the screen, blocking everything.
Now,
You may need to refresh your share. Sometimes
Yes,
it gets
yes.
stuck.
I have the same problem.
okay,
I can see the spider at the back, but in the front, I can see the data set. That's why. Maybe you can minimize the dataset data frame.
mm, do you see now?
No, it's still, I still see the data set in the center.
Um, yeah, I'm not sure about that. I'm sharing the.
It did remove the data set pop-up just now.
Yeah, it's removed.
Yeah, now I just see the spider.
Now it's okay. Now it's okay.
Oh, okay. Okay, now as I was saying that linear regression is not performing better here. So let's see how polynomial regression performs. So here, this is the value what polynomial regression is predicting for level 6.5. So if you see, if you compare with the actual value, you can see that it's closer to 6. 6.5 is a bit higher than 6.5. So it's performing a bit better than the linear regression, which was we think that you know which was even exceeding the level 8 salary. So this was how you can train polynomial linear regression using Python. So now let's move to the for the same data set. If we train it with decision tree, so the data set that we use to train polynomial regression really is a decision tree to see how it performs. And the decision tree is actually used for classification. If you in our Azure foundational course, we have seen that we can use a classification algorithm for predicting even non-discrete and continuous value. So here, decision tree can be used for creating the regression for solving regression problem. How it can be solved here? You can see that for suppose this x1 is a independent variable and x2 is another independent variable. This is our observation. So here, the each split means the leaf of decision tree, and we have observation here. So basically, if you suppose you x1 if it exceeds 20, and if it's below 170, and if it exceeds 20 then and less than 40, so it no matter where the value is, it will be minus 64. So it just determines a value for each leaf, each split, And how is determined? It, for instance, it can be done using the, you know, the average, using the average value of whole data points here. So for this split, it's determining that this split, the value should be 65.7. For this one, 300.5. That's how it determines the value for its splits. Here you can see that if we, that's how the decision tree, is used in regression. In classification, you would have certain class here. Suppose if it's less than 20 and exceeds 200, then it would be class D, and this would be class A. But for regression here, you know we're just setting up a value for this certain split or leave. You can see. So this how decision tree works. Now we will see how we can train decision tree for this data set that we use to train in polynomial linear regression. So let's move to the code. Okay. Um, okay. So this is so we are doing the same. We are importing required libraries. We need to clear that. We're just importing. The library is imported, and now we are getting our data set from this CSV. We are using the same data set that we used in to train our previous model. We are going to predict the salary. The same problem we are solving with using decision tree. And this is also same as the previous section with just identifying the independent and dependent variables. So this is the part where we train our decision tree. We are importing the decision tree from sklearn, the tree, and we are importing decision tree regressor, and it has some um, parameters you can see. Okay, take a bit time. So this particular class will set some parameters.
Syed, your mic must have gotten bumped. You started cutting out pretty bad.
Sorry. Is there any problem? Do you see the screen?
That's much better. Yep, thank you.
Okay. So here, these are some the hyperparameters that you can tune them if you want to, like max depth, minimum sample split. These are this class contains this the decision tree random decision tree regressor contains these hyperparameters. So you can always tune them to get out, get the best result from the tree. So I'm just simply training them using the variable just to show you how you can train them. So we are just fitting x and y and training the decision tree regressor, completed training. Now, if we predict the variable for the value, the salary for position 6.5, let's see how it performs in this case. We have y grid. So it's saying it's, and let's compare with our actual data and see how it's performing. So it's basically saying that level 6 could get salary. It's not performing that well compared to the polynomial linear regression. They're saying that we have to pay if 6.5 level, we pay in this amount of money. It is equal to 6, level 6. So it can be improved using the streaming hyperparameters. And if we want to plot the visualists want to see how it's performing. Here. As you can see, it's not continuous. It's actually as it's a tree, so and it's for each split it's assuming a value. Suppose for if your data exceeds this point, it will have, no matter where the point is, it will have the same value. That's how decision trees perform. So this is how you can train decision tree. Now the last algorithm that we have is random forest, and this is an ensemble learning using, where in decision tree you just use a single tree, but in random forest you use lots of trees together, to predict the value. Basically, it's a bagging, or it's called bagging or bootstrap aggregation, where you train the trees with different splits of data sets, and all the different trees that predict value, then you get the best, the average value. So it generally performs better than decision tree. The single is just single tree, and in here you have lots of tree. You can define the number of tree, and it generally performs better than base algorithm like decision tree. So let's see how you can train random forest in Python. Okay, so we're using the same data set here as well, and now we're importing everything. The required libraries, NumPy, Matplotlib, Pandas, and we're also the same as previous, no change here. Okay, now in random forest regression, we are importing it sklearn from sklearn ensemble as an ensemble algorithm. we're supporting random forest regression, and here we are. This n estimator, this basically means that how many trees do you want? And I'm defining I want 10 trees there, 10 decision trees that will be used to predict the values for y. So let's see how it performs. We trained our random forest regression using the data set. And if you want to predict the salary for 6.5 level, let's see how it performs. And we have it executed, and we can see that that's how it's predicting. And if we compare with the actual data set, we can see that it's actually performing really well. You know, if you compare it with the performance of other algorithms, this ensemble algorithm is performing really well. You can see that the salary for level 6 is this amount, and it's between these two, and it's actually performing better compared to others. Okay, so that's how you can train. And if you plot it using the matplotlib, you can see that that's how it's easily using lots of trees. So you can see that that's how it's plotting the prediction. Yeah. So that was the uh, so that was the end of this webinar.
Sayed, your mic got bumped again.
Yes.
Are you taking questions?
Yes. I'm saying that this was all using this data set. I trained the models using Python. If you want to ask question, you can please.
I have a kind of maybe a basic one, just asking about the using the capital X and then a lowercase y for the variables. Is that convention for machine learning in Python, or is there any other reason for that?
No, it's up to you. You can define variable. It's not required to do that. You can do it as you wish. You can define any name. I just named it X and Y so that we can matches the plots. That's why I defined X and Y. There is no special any reason. You can define anything.
Thank you.
Okay. So thank you for participating this webinar. Basically, this webinar for beginners. I try to do some these projects to show them how actually it works in using Python. We have seen it in Azure that we train the model without using any code. So I tried to show you how you can train using code. So that was it. Thank you for joining. Thank you, everyone.
Thank you so much. That was such a great webinar.
Thank you.
Syed, if you're still on, you might want to end the meeting so that the recording stops.